This is a quick intro or review to solving inequalities with variables in them. And this will be a series of a couple short videos. In the book on page 352, lesson 6-4, this is just talking about inequalities that involve addition. And the intro problem is on the airline that Raul is using, the weight limit for both suitcases combined is 50 pounds. How much can Raul's second bag weigh without going over the limit? So you can see here that the first bag is 38 pounds, and they want to know what can the second bag weigh without taking him over the 50-pound limit. And basically they want us to think about, is there more than one possible weight for Raul's second bag? So what we can do is we can write an inequality. Now, inequalities are an equation where you don't use an equal sign, hence the word part in. They are not equal. So we are looking at using greater than, less than, greater than or equal to, or less than or equal to signs. So anytime you have one of these four in the equation, it is an inequality. So then we want to, after we write the inequality, then we are going to solve just the way we did before for our variable. So the weight of the second bag they have is P. The weight of the first bag is 38. When we combine these two, they need to be less than or equal to 50 pounds. Now, you solve the problem exactly as you do when you have an equal sign here. So you go through the exact same steps. Because they have a positive 38 here, they're going to subtract 38 from both sides, and they find that these two are going to cancel each other out, so you're just going to be left with P, and over here you're going to have 12. So we are using the inverse relationship between addition and subtraction to isolate the variable, and we're using the subtraction property of inequalities. It's just like the subtraction property of equalities. If you do something to one side, you can do it to the other side. Now, one of the differences is if they ask you to graph this, you put it on a number line. And when you have a greater than or equal to or a less than or equal to symbol, you represent that as a solid dot. You fill it in, and then you draw an arrow that represents the possible quantities that fulfill what you discovered in your answer. So we're saying that P has to be less than or equal to 12, because if we add 12 to 38, we are going to get 50, and 50 is an acceptable weight limit. But P could also be 11, and then you would be at 49 pounds, or 10, and then you'd be at 38 pounds, or it could be here at 9.5. So these are the acceptable solutions for P. Now I want to just make one comment here. If this number line went all the way to 0 and to the negatives over here, you would be stopping this arrow, and then you would have another circle, and that circle would be filled in most likely. So I don't really like this number line, but as it's drawn only going to 8, I would accept this, because that's how they have it. So it says Raul's second bag must weigh 12 pounds or less to avoid going over the weight limit for both suitcases. So they're thinking that you have good knowledge, and you know that a suitcase is not going to weigh less than 0, nor is it going to weigh 0. So we can do the same thing with subtraction. Here's an example. The weather forecast predicted that the evening temperature could get as low as -12 5/10 degrees Fahrenheit. Between afternoon and evening, the temperature dropped by 7 5/10 degrees Fahrenheit, which was consistent with the forecast. What could the afternoon temperature T have been? So the first step is to write an inequality to represent the situation, and then you solve as you normally would. So they're taking T, the afternoon temperature, and we know that the temperature dropped by 7 5/10 degrees Fahrenheit. So that's a subtraction. And that temperature has to be greater than or equal to a -12 5/10 degrees Fahrenheit. So here they're going to use the addition property of inequality, which is very similar to the addition property of equality. You're going to add the same number to both sides to isolate the variable. And here we see that T has to be greater than or equal to -5. So down on the number line again, because we have the equal to portion there, we're going to put a solid circle right there, and we're going to draw an arrow to the right. Now, down here on example 3, they're just asking us to solve this inequality. Notice there is no line under the less than sign. It's just saying that x minus 1/2 is less than -2/3. So we're going to use the same strategies that we've always used. We're subtracting here, so we're going to add the opposite. The inverse of -1/2 is +1/2. We're going to add that to both sides. You'd have to find a common denominator here of 6. And when you do that, you're going to find that x is less than -1/6. So you'll notice that our graph in our solution right here is different. We find -1/6, but instead of a circle that is filled in, we have a circle that is open. And that means that this number right here, which is -1/6, is not included in the solution set, but anything to the left of it is included in the solution set. It would work for this situation here. So that is one of the important understandings here, is that if you don't have the line underneath, when you graph, you have to have an open circle versus the closed circles that were on the other two. Now this lesson is only on when you add or when you subtract inequalities. There's another video I'm going to do on what happens when you multiply, and there's a little tweak there. So this is the end of the video for how to solve inequalities when you are using the addition property of inequality or the subtraction property of inequality.